Hello, this is the physics lab for oscillations. Introduction. The purpose of this lab was to observe and analyze a spring mass system, and then using tracker, we found the observed motion and we compared it to the predicted motion that we made using GliScript. Then we plot the change in position of predicted versus observed motion, and then we plot the change in energies of the two motions, or of the predicted motion. First, let's talk about the energy principle. The energy principle says that the change in total energy of the system is equal to the work done by the surroundings plus the heat exchange. It also states that the energy is neither created nor destroyed. Since the system was the spring, earth, and block, and there were no surroundings, means that there was no work done on the system by the surroundings, so the change in total energy of the system should be zero throughout the experiment. Second Newton's law, these are the formulas that we use. We use second Newton's law, so we use velocity update formula and position update formula. And then the energy formulas we use was the work of surrounding plus the heat, or delta K plus delta U plus potential energy of gravity and plus potential energy, change in potential energy of spring equals change in energy of the system, and other formulas. Here's the tracker. It shows the tracker software that we use to track the observed motion, and it shows you the points that were clicked to get the values that we use for the observed motion. Here's my GliScript, which we were given the ball mass. We were given the spring stiffness, and we were given the relaxed length. And then in the bottom, there's the calculations, which uses the formulas that were mentioned before, such as position update and velocity update, and then the energy formulas, so we could calculate here. Here are the graphs, the three graphs. The one on the left is the change in energy versus time. And the two on the right is the top one is the x position versus time, and the y position versus time. What does it mean? For your model, is the energy principle satisfied? Yes, the energy principle is satisfied because the spring potential and gravitational potential are opposite, and the kinetic energy oscillates so that it changes, so that the change in energy is zero. You can see this in the graph by the red being gravity and green being spring. They're always equal in amplitude, but opposite. They're on opposite sides. One's negative and one would be positive, which they cancel out. And then you can see through each full oscillation of delta K, it always equals itself out throughout the entire thing, meaning that delta E is always zero. And then here's another, what does it mean? The average oscillation period for X during our spin run was around 1.7 seconds, while the oscillation period for Y was like 1.6. The difference could be due to that not account for some forces such as drag or any human error, such as during clicker, the tracker, I might have messed up by doing that. Or when we were doing the actual experiment through the tracker, might have messed up. Just basic human error that could happen, which led to that not being the same. Thank you.